Okay, we're in, this is Tech Math 2, and we're in section 6-6. And the video I made the other day for 6-4 and 6-5 is missing the first 10 minutes of that video. So maybe we'll recoup something here, but we get to do it again anyway, so it really doesn't matter that much. But for those who are watching it, will know that that's the case. The issue is, if I have 4x plus 3y is equal to 1 and 4x plus 3y is equal to 2, do those set of equations have an answer?
Yeah.
And the answer is no, they don't, because the first one says y is equal to minus 4 over 3x plus 1 over 3. And the second guy says y is equal to minus 4 over 3x plus 2 over 3. So they both have the same slope, so they're parallel, and they have different y-intercepts, so that means they're parallel and they never cross each other. They're not going to see a solution. So there's no solution there at all. These lines are parallel. Well, if I look at the coefficients of the x and y's, and I go 4, 3, 4, 3, and I take the determinant of that, then I get 12 minus 12 is 0. One of the rules we had yesterday on determinants was that if two of the rows are the same, then the determinant is 0. Okay, so that is telling me that I don't have a solution. All right, now, if I have something a 1x plus b 1y is equal to c, and a 2x plus b 2y is equal to c2, and that's c1, and I decide I'm going to solve these by substitution. So I say y is equal to c1 minus a1x divided by b1. And I'm going to put that into here, and I'm going to say a2x plus b2 times c1 minus a1x divided by b1 is equal to c2. And then I can say a2x plus b2c1 minus a1 b2x over b1 is equal to c2. And then I can say a2 b1x plus b2c1 minus a1 b2x is equal to c2b1. And I apologize for that lack of alphabetical order. And then I could say a2b1 minus a1b2 x is equal to b1 c2 minus b2 c1. And then I could say that x is b1 c2 minus b2 c1 divided by a2 b1 minus a1 b2. And then I'd be done. And I could do that over and over again for many different equations, 2 equations, 2 unknowns, and I'd end up with the same answer. So it doesn't matter what my coefficients are, I'd end up with the same answer every single time. I could do the same thing with 3 equations, 3 unknowns, and I could end up with the same answer. It would look different than that, it'd be more complicated, but I could do that. Okay. So prior to TV, prior to radio, prior to the internet, that's what mathematicians did. They solved 3 equations, 3 unknowns, but they always came up with the same pattern. So they decided, well, if we could figure out a shorthand way to explain that pattern, then we could solve 3 equations, 3 unknowns, not use substitution, not use addition and subtraction. We could have a different way of doing it because we already know the answer. We could memorize this answer and just write down the answer and not do any of the steps that came above. So I could go and say 2x plus 3y is equal to 4, and x minus 4y is equal to 3. And I could just say, well, gee, what's x? Well, x is going to be b1, so that's a 3, times c2, which is 4, minus b2, which is a minus 4, times c1, which is a 4, divided by a2 times b1 minus a1 times b2. And I could come up with x is going to be 12 minus 16, which would be a minus 4, divided by 3 plus 6, which would be a 9. So x would be minus 4 over 9. And I wouldn't have to go through all it. Is that the right answer? Anybody know? So if I turn my calculator on and I go to simultaneous equations and I put in a 2 and a 3 and a 4 and a 1 and a minus 4 and a 3, I tell it to solve, and I get x is 25 over 11. Anyway, so maybe I put it in right, maybe I didn't put it in right. But the issue is that once I see this form and I see it over 100 years by thousands of mathematicians, someone's going to figure out a shorthand way of writing it. Okay, so that shorthand way of writing it is called Cramer's rule. Cramer's rule. And what it says is that if I have something in the form a1x plus b1y is equal to c1, and a2x plus b2y is equal to c2, then I can write x. And x is going to be, well, we'll put something on the bottom first, is going to be a1, determinant a1, a2, b1, b2. And then because I'm asking for x, I'm going to substitute in the c guys on this side, c1, c2, b1, b2. And because we already did determinants, we know that this is going to be c1, b2 minus c2, b1. And on the bottom, I'm going to have a1, b2 minus a2, b1. And now I have that. So this is my shorthand way of saying I can solve 2 equations, 2 unknowns by just taking the determinant of the numbers sitting in front of the x and the y. And I can do the same thing for y. Y is going to be on the top. I'm going to keep my a1, a2, and I'm going to substitute what's on the other side of the equal sign, c1 and c2. And on the bottom, I'm going to keep the same guy. So I only have to calculate him once. Once I have him, I can find, once I solve him for x, I can just use that same number over again in my y guy, and everything's going to be fine. And in fact, this is what your calculator does when you put in 2 equations, 2 unknowns. That's what it's physically doing. It's solving Cramer's rule. And then that worked fine for 50, 60 years. And then Cramer, who probably died by then, said, okay, well, what if I have 3 equations, 3 unknowns? A plus bx, b1y plus c1z equals d1. And a2x plus b2y plus c2z is d2, and a3x plus b3y plus c3z is equal to d3. What if I have that? Well, if I do, then my x becomes, and on the bottom, I just keep the coefficients of the x, y's, and z's. and I find that. And then on the top, for the A column, I substitute what's on the other side of the equal sign, which in this case are the D's. And how could I be so hosed? Somebody was going to tell me about that, right? Well, Ben's not here, so he can't tell me. Well, we'll blame him then. And then I can do that, and it's a 3 by 3. I can solve a 3 by 3 determinant. So I'll do that, and I get the answer for x. And then if I want y, I do the same thing over again. And on the bottom, nothing changes. I keep the same thing, but a1, a2, a3, d1, d2, d3. So I'm substituting in, because I'm asking for the y answer, I'm substituting in for the y what's on the other side of the equal sign. And so now I do just one determinant to find y, because I already did the bottom guy when I went to find x. And then if I want to find z, I can do the same thing. A1, A2, A3, B1, B2, B3. And I substitute the d's in, and I have the same thing on the bottom again. And in fact, I can do it by 4 by 4s, 5 by 5s, 6 by 6s. It doesn't matter. The same theory works, and I can come up with the answers for A, B, and C. Now, think about two lines. What can they do? Well, they can be parallel and not have an answer. They can be the same line and have multiple answers. They can meet at a point, right? When you do 3 equations, 3 unknowns, what is that 3 equation, 3 unknown the equation of? Okay, so I got 3x plus 4y plus 5z is equal to 2. What's that the equation of? There's x, there's y, here's z. When y and z are both 0, then x is going to be 2 over 3. When x and y are both 0, then y is going to be a half. When x and y are both 0, then z is going to be 2 over 5. Okay, so that's a point there, over here, and up a little bit. There's a point right there. And then I'd have to find another point. This becomes a line. So this is a line in 3-dimensional space. Now, lines in 3-dimensional space, if I have 2 of them, do they have to cross? They got one going this way and one going like that. Do they ever cross? No, they're not going to cross. And so if I have 3 lines in 3-dimensional space coming to a point, that means that all 3 had to cross at the same point. Okay, so if you're looking for the solution to 3 equations, 3 unknowns, do it for problems that are in the book. Do it for problems that you make up in your electronics class that are physically real, and you'll come up with the answer. Randomly pick numbers and put them down on your sheet of paper and try to solve them. Chances are you don't have an answer. Okay, and so that would be a problem too. 4-dimensional things, x, y, z, and t for time, for example, well, they may or may not have an answer either. So as you get to multiple things, multiple unknowns, you're stuck with doing the problems in the book so that you know you can have an answer to them. Okay, questions about that? All right. Now this is Cramer's rule. Well, my favorite way of solving simultaneous equations is with my calculator. But my second most favorite way is Cramer's rule. I don't have to write down an x, I don't have to write down a y, I don't have to bring them with me, I'm not doing a substitution. The chances of doing an error is considerably less. Alright, so I'm going to look at problem number 1 so we can get warmed up. And I got 3x plus 5y is equal to minus 1. 2x minus 3y is 12. And I say, well, what's x? Okay, so x is going to be minus 112, 5 minus 3, 2, 3, 3, 2, 5 minus 3. Okay, so I've got minus and minus, so that's 3 minus 60 divided by minus 9 minus 10. So that'd be a 57 over 19. And minus minus, right? So that looks like a 3. Does that look like a 3? 57 over 19, yeah, it looks like a 3 to me. Okay, so x is going to be 3. And then for y, I'm going to say, well, on the bottom I have minus 19 because nothing changed. And on the top I have 3, 2, minus 1, 12. So I've got 36 minus a minus 2 divided by minus 19. 38 divided by minus 19 appears to be a minus 2. So x is 3 and y is minus 2. I go back up. If x is 3 and y is minus 2, then that checks. If x is 3 and y is minus 2, then that checks. So those two answers check, and I imagine somebody put it in their calculator and already knows that anyway. So now I didn't do substitution. I didn't have to write down y's and x's all over the place, keeping track which one they are. And my answer came out pretty reasonable too. But it is one that the author made up, so naturally it was going to come up with the right answer. If they're parallel or they're the same line, then the determinant of the denominator becomes 0. I can't divide by 0 and I don't get an answer. So that's the way that works. All right, we're looking at number 3. 8 minus 3 is equal to minus 43. 5 minus 7 minus 73. You gotta be kidding me. All right, so x is going to be on the top. I'm going to have minus 43 minus 73 minus 3 minus 7 divided by 8, 5 minus 3 minus 7. Oh well, minus 7 times minus 43 minus minus 73 times minus 3 goes on top, and clearly we'll have to use my calculator to figure out what that is. Let's see, 8 times 7 is 56, right? So that'd be minus 56 minus a minus 15. Okay, so the bottom gets a 41, minus 41, minus 41. And the top gets 7 times 43 minus 3 times 73. Gets an 82. So my x is going to be a minus 2. Now, we could take that minus 2, put it back into this equation, one of the two equations, and come up with y if we wanted to. But that's not the purpose, so we'll come back and y is equal to, on the bottom, I know I got a minus 41. On the top, I've got an 8, 5, minus 43, minus 73. So I'm going to have minus 41 on the bottom. 8 times minus 73 minus 5 times minus 43 8 times minus 73 plus 5 times 43. So I've got a minus 369 on the top and a minus 41 on the bottom. So that looks like a 9. So x is minus 2, y is 9. Come back up and check. If x is minus 2 and this guy is 9, that's 27 plus 16, which is 43 with a minus sign. So the first guy checks, the second guy is going to check too. There's no reason for me to do that.
You write down.
Move down.
Yeah. Okay. You good?
Yeah, I'm good.
Yeah.
Yeah. Good or just plain lucky?
Lucky.
Lucky. Okay, we're lucky. Okay. All right. So we'll move down to number 13. And it's always good to write the equation in the form that we expect it to be. Okay, so I'm going to change this to minus 4x plus y is equal to 0. Not going to write it down the way the book has it, because they wrote it down that way just to confuse you. So x, I've got 8 minus 4, 7, 1 on the bottom. And I got 18, 0, 7, 1 on the top. And that's always convenient to have a 0. So I've got an 18 divided by 8 minus 28. Minus a minus 28. So that'd be 18 divided by 36, which appears to be 1/2. Okay, so x is going to be 1/2. And then we're going to solve for y. On the bottom I've got a 36. On the top I have an 8 of minus 4, an 18 and a 0. So I'm just going to go minus 4 times 18 divided by 36. I recognize that 2 times 18 is 36, so that's going to be a minus 2. All right, we're going to go back and check our work. 1/2 minus 2. So 1/2 minus 2 does not make 18. 1/2 minus 2 does not make 0. So what did I do wrong? Okay, so that's 8. 28 is 36. That has to be right. 18 on top. That has to be right. 8 minus a minus. This is a minus 4. Okay, so that becomes a plus 2. So if I'm plus 2, then I've got 4 plus 14 is 18, and I've got minus 2 plus 2 is 0, and my answer checks. So when I go the other diagonal, it's minus that other diagonal, which I didn't put in. Okay, so that was an all right thing to do. Now we come up with the 3x3 guys. Bummer, I don't believe it. I didn't assign a 4x4. Or did I? Yes, I did. I assigned a 4x4 one. All right. We'll worry about that later. All right, so we'll do 34 next. And so 34. I've got 3x minus 5y is 20. And I've got 9x minus 8y minus 2z is minus 25. And I got 5y minus 8z is 8. Okay. Now, I remember that this is plus 0z, and this is 0x plus. Okay, so when I do my determinants, I have to have those other zeros in. I remember that. I don't write it down, but I remember that I have to do that. All right, so I say, well, gee, x is going to be 20 minus 25, 8. Minus 5 minus 8, 5. 0 minus 2 minus 8. And on the bottom, 3, 9, 0. Minus 5 minus 8, 5. 0 minus 2 minus 8. Yes, Nate?
Okay, you got minus 5, and that would be positive 8, not a minus 8.
Right here is minus 8.
No, in the book it's 8, positive 8.
Oh, wow. Yeah.
Okay, just making sure.
Yep. Mm-hmm. Yeah, copied that down wrong. Don't want to proceed past there. Maybe that. Now, your calculator will give you the answer to this. So, that's just one of those things. All right, so I go in and I say, well, what do I got? 20 times 8 minus 8 plus minus 5 times minus 2 times 8 plus 0 minus, going the other way, a 0. Normally I wouldn't put down the 0. And I've got minus 10 times 20, so that's going to be minus 200. And then I've got a minus 8 times minus 25 times minus 5. And on the bottom, I've got 3 times minus 8 plus, that's a 0. 0, that's another 0. 0 minus, going that way, that's a 0. Normally I wouldn't write down the zeros, I'm just doing it for the good of the order. I got 30, so it's going to be a minus 30. And I've got plus 8 times 9 times 5. Okay. So now I take out my calculator. 20 times 8 times minus 8 plus 80 minus becomes a plus, so it'd be plus 200 minus 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 minus, so that becomes a plus, so plus 8 times 25 times 5 equals. So I have a 0 on top, 0, divided by 8 times 64 plus 30 minus 8 times 45. Okay, and I've got a minus 1380 on the bottom. So my x becomes a 0. Now there's no reason x can't be a 0, so I would assume that it's probably okay, unless somebody puts it in their calculator and tells me it's wrong, and then I'd change my opinion. So y is going to be, on the bottom, minus 1380. On the top, 390. 20 minus 25, 8. 0 minus 2 minus 8. Alright, so I've got 8 times that is 200. 200 times 3 is 600. So I'm going to have 600. The next guy is 0. The next guy is 0. Minus I've got a 0. I've got a 4 times 8. 6 times 8 minus 48. And I've got a minus 8 times 9 times 20. And underneath I got a minus 1380. Alright, so I got 600 plus 48 plus 8 times 9 times 20.
So I got a different bottom number.
You got a different bottom number? What'd you get?
Negative 522.
Minus 522. Okay, so we got to do the bottom again. 3 times 64.
Well, if you want negative 8, should be a positive 8 too again.
Oh, bummer. I corrected it there, but I didn't correct it there. Doesn't that just torque you off? Alright, so that becomes a positive 8. That becomes a positive 8. Alright. So that should make the guy more negative, shouldn't it? 3. Alright. Minus 3 times 64 plus 30 minus 8 times 45 equals, and you get minus 513.
522.
Okay, so I need 3 times 3. I put the wrong number in. Minus 3 times 64 plus 30 minus 40 times 9 minus 522. Okay, we'll go along with that. Alright, and this guy is minus 522. And this guy is minus 522. And I didn't write down what the other guy was, minus 522. And on the top, what I have, 600 plus 48 plus 8 times 9 times 20. And I have 2088, which becomes a minus 4. Okay, so I got y. Now I'm looking for z. Now at this point you'd normally put x and y back in the equation to get z, but because we're in this chapter of the book, we're gonna solve for z anyway. Okay, so I got minus 522 on the bottom, and on the top I have something that I have no idea what it is because I can't find it. So 390. Well, I just look at the problem, right? 390 minus 585 and 20 minus 25, 8. All right, so 64 times 3. 3 times 64, that's a 0. And this is plus 20 times 45 minus, that's a 0. This is 15 times minus 25. This is minus 40 times 8 divided by minus 522. All right, so 3 times 64 plus 20 times 45 equals. Okay, so I've got that. Next guy is a plus 15 times 25 Next guy's a plus. Plus 40 times 8. So I got 1783 divided by 522. I don't think it divides by 522 very well, does it? 522. And it doesn't. So that means that I probably made a mistake. I'll come back to the problem. 390 minus 5, blah, blah, blah. And it's 20. Okay, so 64 times 3, 0. 20 times 45. Okay, I've got a 0 that way. 15 times 25. And I've got a 40 times 9. That's a 9. All right. So I have to add another 40. So if I added another 40, that would be 1, 6, 2, 3. And I don't like that either. All right, so 30.
I got 1107.
You got 1107 on top?
Yeah.
I don't like 1107 either. 6 times 64 plus 20 times 45 plus 15 times 25 plus 40 times 9 equals. Wow, how could I get that? I know how I got that. I put in 33 times 64. All right, 3 times 64 plus 20 times 45 plus 15 times 25 plus 40 times 9.
Yeah, I got one.
All right, so now I got 1827 divided by 522. 3.5. All right, now I've got numbers that I can check. So no, no, that's good. So if I check a 0 for x and a minus 4 for y and a 3.5 for z. 3.5. So the first guy checks. The second guy, minus 4. So minus 4 times 8 is 30, minus 32, right? So minus 32, that doesn't check. Minus 30, is it minus 4 for 8? Yeah, it's got to be minus 4 for 8. This is minus.
Yeah, it should be negative.
That's a minus. All right. All right, so this is minus. So I got 32. I got minus 32 plus 7. So that guy checks. All right, that guy checks. And then I got 20 minus 20 plus 8 times 3.5, boom, and that's 8, so it checks. So all three of them check back in the work, and I'm done. Now, the issue is, can we do 38 in the time remaining? Saying that we goofed off and spent too much time on that one. All right, so 38, we won't write down the problem. Okay, so I want, on the top, I want 38 minus 28 minus 3, 23. And I want 2, 4, 0, minus 2. 2, 4, 0, minus 2. And then I want 1 minus 7 minus 5, 0. 1 minus 7 minus 5, 0. And then I want 1, 1, 0, 7. 1, 1, 0, 7. And because this is a 4x4 guy, we have to turn it into a 3x3 guy before we can solve it. So that doesn't bode well for much of anything, right? And we're solving for x. Okay, so solving for x, I've got 8, 0, 3, 3. And I've got 2, 4, 0, minus 2, 1, minus 7, minus 5, 0, 1, 1, 0, 7. Okay, so that's what I have to do. And clearly I am hosed unless I have a better calculator than what I had, because I'm hosed because my calculator doesn't do 4x4s. Now, some of you, the TI-89s do. And I'm pretty sure you just put it in there and have it come
All
up.
the way up as high as you want.
Yeah, so, well, there is a memory size, but you're not going to get there. All right, so now the issue is, how am I going to solve these determinants? So, in 5 minutes, how am I going to solve these determinants? Okay, so that's the issue. So, we're going to look at this guy first and solve him. Copy. All right, so so it looks like I'm going to expand him across there. That's what I'm going to do. So this is going to be minus 1, 1, 2, 3, 4 to the 4th times 3 times what is remaining. I want to get rid of that guy. Okay, so I got 2, 1, 1, 4, minus 7, 1, minus 2, 0, 7. Plus minus 1 to the row plus column. Well, that's a 0, so it doesn't matter. So the next guy is minus 1 to the row plus column. 1, 2, 3, 4, 5, 6 to the 6. Times minus 5 times what's remaining. So I get rid of him, and I have 8, 2, 1, 0, 4, 1, 3, minus 2, 7. And the last guy is 0. Okay, so that should be reasonably okay. So minus 1 to the 4th is plus 1, so I got 3 times 2 times 49, which is 98. So I got minus 98. 1 times minus, so that's minus 2. And then 1, and that's a 0. So I got a 100 minus, going the other way, 14, that's a 0. And 2 times 4 is 28. Okay, this is minus 1 to the 6 is 1, so that's going to be minus 5 times, okay, so 8 times 4, 8 times 4 times 7 is 224, 224. Plus 6, the next guy is a 0, minus 12, minus 16, and the last guy is a 0. All right, so I got 3 times 100 minus 30, 42, minus 5 times 240, 230. 230 minus 4 plus 4 plus 4. And so I got 3 times 58 minus 5 times 234. So it looks like I've got minus 996 on the bottom. All right, now that I've got minus 996 on the bottom, now I have to solve for the top half of the x, the top half of the y, the top half of the z, to get the answer. And with less than a minute to go, that's not going to happen. So that means you'll have to do it on your own. Think you can do it on your own? Yeah, I think you can probably do it on your own.
So what we do, when we're doing the top half, we put basically what our answer would be in place of the unknown. Correct?
You put what's on the other side of the equation
On the
for the unknown you're solving for, yes.
so I thought, okay.
And you keep the rest of the coefficients exactly where they are. And
we
because
bottom,
yeah,
you basically take
x, y, z, x, y, z, yeah, x, y, w, z, yeah.
Okay.
Yeah, in order. So the columns are lining up where the x's are. I don't have to write the x because I remember it's in that column. The math remembers that the x is in the first column, the y is in the second column. And that's why it works. All right. Oh, next class is even going to be better. Partial fractions. Wow. That'll be cool. Now, this is sort of like accounting. You can't make a mistake if you do your host. So, as soon as you write down a minus sign where there's supposed to be a plus sign, things go bad right away. And I don't guarantee that my 961 is correct. But I could.
I got 348 negative.
You got 348 negative? Because I could go into Maple and put that in, and I'd know what it was. But right now there's some question whether or not the instructor's answer for what's in the denominator is correct. So the rest of you can go away, and the instructor will, or not, and the instructor will sit here and figure out how to do this. Help. Yes.
I'm not going to be here Friday.
Okay. There'll be a quiz on the web. And
Alright, you
it'll
should be
be,
print it off.
yeah, just print it out and bring it in.
Okay, thank you.
Hey, Jackie.
Look at that there.
Take a walk back.
Just looking about the parking actually out. Yeah.
Alright, so I've entered the matrix, and now I'm going to ask it to calculate the determinant. And I'm missing a parentheses. Well, isn't that special? Alright, well, how do I bold that, I wonder? Alright, well, go back to help. So, minus. So it looks like the instructor was correct with minus 984, assuming the instructor had minus 984, which he doesn't. So it looks like minus 984 would be a better answer. And 8211. 8211. How come I have 8 minus 2? Oh, it is minus 2. Bummer. So our original equation needs a minus 2 sitting right there and sitting right there. Bummer, Zulu. All right. So that answers that question.